What do we really know about carbon? What it looks like? Feels like? Smells like? Tastes like? From experiments, we came up with 6 protons and 6 neutrons in a dense center surrounded by 6 orbiting electrons at a radius of 69 picometers. Except, every so often, some part of the description proves to be problematic. Bohr's electrons can't orbit like our planets do around the Sun. So they added precession around the bag of marbles to make a shell. Except, then the velocity and position are indeterminate. Enter the wave function. That gives us a 1s electron shell, a 2s electron shell at a larger diameter, and 2 orthogonal axial electron plumes, with a single electron in each. How do we get 120-degree bond angles or trigonal pyramids from orthogonal or spherical electron shells? Bonding has the octet rule. The Lewis structure was the first bonding method that worked, sometimes. Ionic, covalent, van der Waal, and London forces explain some of the holes. Vesper joined with geometric shapes, but not always. Band-aid after band-aid. What is the source of the problem? The basic problem lies with the standard model structure of the atom. Quantum mechanics. The bag of marbles with a smear of indiscernible electron waves surrounding it. Supposedly, the interior of the atom is made of protons and neutrons held together by a strong and weak force. Electrons stay in orbit near a positive nucleus without spiraling inward and attaching to the nucleus or ejecting each other into space. There are so many issues with the standard model of an atom. Even more difficult to accept is the concept of protons and neutrons built from quarks, gluons, and other particles from the zoological set of subatomic particles that spawned this. It looks like a Christmas tree gone wild. The CERN collider should have pushed physicists to follow a different path since we see all of the subatomic particles are curving away from the point of impact. That indicates spin, mass, size. The existence of which current physicists deny. The standard model of quantum mechanics is all about point-like, massless, wave forms. But, admittedly, since it works at the macro level, we can't just throw it out without something better to replace it. Miles Mathis has spent 30 years rewriting physics using the same data as the physicists. Except, he is not bound by the physics journal system where he has to write papers that can win the approval of the establishment. Instead, he has written physics to be logical, concise, consistent, and, most importantly, mechanical. Connecting the physics to underlying mechanics is a requirement in his work. And his work makes sense. Until we get to his proposal for the neutron and how to build the nucleus while ignoring the neutron. Let's start with one of the basic premises of Miles Mathis physics. There is no energy in the vacuum of space. Space is only a volume by definition. Atoms inhabit that volume. Photons, having mass and size, inhabit the vacuum. This is the debacle of dark matter, dark energy, zero-point energy, magnetism, electricity, and the ultraviolet catastrophe. Photons are the energy that exists in the space that Kim Griest talks about. Miles has found that the proton emits 19 times its own mass in photons every second. The vacuum of space within the Van Allen radiation belt around the Earth is filled with photons, especially within the atmosphere of the Earth. The majority of photons exit normal to the Earth's surface. The photons exiting the Earth collide with the photons arriving from the Sun and build to the light that surrounds us. That is why the Moon seems to reflect more light than it receives from the Sun. The Moon has a gray, non-reflective surface, and yet a full moon appears brilliant in the night sky as seen from the Earth. The proton is just as Miles has described it. The ambient photons enter the proton at the poles and are emitted at the equator of the spinning proton. But what do the internals of a proton look like if it doesn't look like a psychotic Christmas tree? Is it just a massive jumble of quarks held together by gluons? Chaos and constant motion? How does it even hold together? A proton is built from the charged photon, the smallest of the photons in the infrared region. So how do photons build to a proton? When two charged photon particles collide, they either bounce apart in different directions or stick together, spinning, like when a cue ball attaches to the colored ball. In the pressure and density of the Sun's corona and the Earth's core, these photons will collide in the densely occupied space and either build to the next size bigger photon or smash apart to the next size smaller photon. Once there are enough collisions that build, a proton is created. Photons are emitted from the proton and it is identified as hydrogen. This same process occurs within the proton. Hence the strange integer multiples of the Rydberg constant that led physicists to believe electrons teleport from one energy level to another. The kernel of the proton emits the ingested ambient photons. Those photons collide and build within the proton's Bohr radius. Most photons are recycled through the proton, but a significant mass of photons are ejected at the proton's equator. The collision between different size photons create concentric shells. Each consecutive outer shell is related to a smaller size photon. Hence, the smaller radius found when bombarding a proton with a meson as compared to that which was found when bombarding the proton with the larger electron. The proton is a hydrogen atom with an electron circling the poles. But what about the neutron? How does the neutron become a proton within 15 minutes of being ejected from an atom? Miles says it is a proton with a reversed outer spin. The spin causes the photons to move from input pole to opposite pole instead of being emitted at the equator. In my opinion, that is not the most likely answer to what a neutron is. If it were, then the hydrogen atom would be most likely built in this fashion. Or this fashion. According to the Royal Society of Chemistry, the hydrogen built without a neutron is the common one. And the hydrogen built with a neutron is incredibly rare. 1 in 1,000 rare. And hydrogen built with 2 neutrons is unstable. That means the neutron must operate in a different manner than Miles has proposed. So let's see if we can pull the major points together and figure out how the neutron operates. First, the neutron follows a curved trajectory, which indicates spin. Second, it changes from a neutron to a proton within 15 minutes of exiting an atom. Third, it rarely joins a hydrogen atom. Fourth, it joins all other atoms in near 1-to-1 ratios with protons in stable atoms. Fifth, it does not change the atom's main characteristics when found as different isotopes, in most cases. A possible solution is this. A neutron is a proton caught in a powerful stream of photons such that it is spinning sideways to the incoming stream, with the stream wrapping around the neutron's equator instead of the stream entering at the poles. There are numerous videos showing examples of round and cylindrical objects caught in a stream of air or water. Notice how the water wraps around the object's surface while maintaining the object's distance from the stream as a balance between gravity and the stream's momentum. So once again, the hydrogen/proton looks like this normally. If it can capture a neutron, it will channel charge like this. Notice that this is not symmetrical. The proton equatorial emission is the stream that captures the neutron. The neutron in turn captures that section of the emission and redirects it back into the leeward pole intake. Since the windward pole intake is aligned to the charge wind, the equatorial emission will protect the neutron once it is in position on the leeward side. The leeward intake is still pulling in ambient charge, so the neutron is also protected from disruption by the leeward intake and the stream wrapping around the neutron. Due to the disruptions caused by the pressures and density of charged photons during the crucial hydrogen build moment, this particular structure only survives in 1 of 1,000 hydrogen atoms. This naturally occurring isotope is called deuterium. There is a third hydrogen build called tritium. Let's take a look at what happens when we have 2 neutrons embedded in the hydrogen atom. This particular build is unstable and does not occur naturally. This time, both sides of the equatorial stream are redirected into the leeward intake. This exposes at least one of the neutrons to constantly disruptive crosswinds. The neutron becomes unstable, flipping into the intake of the main proton but still attached to the neutron stream. This is the process that converts a neutron into a proton, creating an helium-3 atom. There is no place to put a third neutron without removing the equatorial shield completely. 3 neutrons would position at 120 degrees from each other and be pummeled by the charge wind and crosswinds. Additional neutrons added to an hydrogen atom is a lesson in futility. Hydrogen is the easiest to explain, so let's move on to a more difficult atom, helium. Miles puts the 2 neutrons in between the 2 protons as columns to prevent the 2 spinning protons from meeting in the middle. Once again, since Miles neutrons pass charge pole to pole, it makes more sense to put one on top, one in between, and one on the bottom. What does the Royal Society of Chemists say about the build of the helium atom? Only 2 neutrons. And 1 in 10,000 helium atoms will survive the build with a single neutron. Does the new method of neutron operation agree, or does it cause problems also? This is helium-4. Even though hydrogen with 2 neutrons is unstable and has a half-life of 12.3 years, adding in a second proton into helium-4 creates a stable atom. How? First off, one intake of the main proton is aligned to the charge wind. But once again, 2 neutrons are hanging off the leeward sides and subject to possible stripping by the charge wind. This time, however, the vertical proton's intakes will reduce the density around those intakes and the wrapped stream will provide additional protection. The vertical proton expresses its equatorial emission like a rudder. The 2 trapped neutrons will always be shielded from any leeward disruptions by the main proton's partial equatorial shield and the lower density zone created by the vertical proton's intakes. Low density is key that keeps the larger atoms structurally sound. Radioactive atoms have neutrons and protons in areas where the density is subject to charge wind disruptions. This works for helium-4. What about the rare helium-3? Why is it so rare? As you can see, once again the build is lopsided. The neutron is exposed during the creation process, but once it is built, it is protected and creates a stable atom. The vertical proton is not actually vertical, it is tilted towards the single neutron, further limiting the incursion of any disruptions caused by the charge wind. Once again, there is nowhere to safely insert a third neutron. Placing it on the windward charge side of the equatorial emission will subject the neutron to sideways crosswinds. Removing both of the neutrons removes the equatorial feed into the vertical proton's intakes. Without the equatorial emission feed into the vertical proton will starve. The main proton's leeward intake will grind the vertical proton into smaller and smaller particles until it is completely ingested into the main proton. Now that we have a definition for a functional, operational neutron, and we have discovered that it is not just a superficial cog, but indeed an integral part of forming a stable atom. Let's see how it integrates into the carbon atom. This is going to be much more difficult to build. So why not build lithium next, or beryllium? Because carbon is the most versatile atom. And showing how carbon forms molecules without using electron bonding is the end goal. First, we need to look at Miles' carbon atom. The placement of the neutrons. With 2 neutrons between 2 protons. But then 2 protons without neutrons between the protons is a contradiction if we follow his reasoning. Carbon exists as a C12 atom. But there is a second stable atom, C13, with an extra neutron. And a semi-stable atom, C14, with 2 extra neutrons. How do we build these beasts? We start with a hydrogen atom as our main proton in a horizontal position with an intake aligned to the charge wind. Miles has named this proton the carousel center. Next, we place 3 protons 120 degrees, oriented vertically, around the perimeter of the carousel center. These 3 protons are the carousel protons, and they feed directly from the carousel center's equatorial emission. Where the equatorial streams of these 3 carousel protons collide, a coherent, spinning plume is created. The external intakes of the 3 protons receive a reduced charge uptake since they are oriented 90 degrees to the main high-density charge wind. Temperature is the measure of the density of the ambient charge. A higher temperature equates to a higher ambient charge density. In order to stabilize the 3 carousel protons and lock them into place, there needs to be a charge feedback loop. Neutrons need to be placed at the top of the carousel proton equatorial emission and at the bottom of the equatorial emission. The first question that comes to mind is, why isn't this beryllium? It is beryllium-10. But it is radioactive and decays to boron-10. The neutrons are exposed due to the large neutron feed streams, concurrent with a very weak carousel center proton intake at both the top and bottom. The charge wind will eventually strip one of the neutrons from the carousel position, forcing it into line with the carousel center proton. So where do the other 2 protons go? 4 protons and 6 neutrons do not a carbon atom make. The next proton will go vertical, feeding into the carousel center proton. This proton will align to one of the neutron streams from one of the carousel proton's neutrons. Of course, that gives us 5 protons and 6 neutrons. Boron 11, the more common version of boron. Boron 10 is non-symmetrical, which reduces its likelihood of surviving the creation process. While boron 11 is symmetrical and makes up 80% of the existing boron atoms. The final proton will become a charged wind shield, making carbon 12 the most stable version of carbon. This proton is affixed to the vertical axis proton. This proton will align itself to the incoming charged wind. The carousel will be shielded behind it, and the vertical axis proton will maintain a low pressure zone between the carousel and the shielding proton. Since the vertical axis proton receives a charge stream from the carousel, the leeward side of the shield proton is firmly attached. But since the vertical axis proton is receiving a charge feed from the carousel neutron, the shielding proton will not ingest the vertical axis proton. Because the carousel exterior intakes are sideways to the charged wind, they are not receiving a full intake unless some extraneous, side-bearing charge disrupts the ambient charge. The carousel proton intakes keep the 6 neutrons protected from any disruptive charged wind that may occur. The carousel constantly shifts to remain behind the shielding proton like a spinning top. What about the other carbon isotopes? Why is carbon-13 stable? This is carbon-13. We see the same asymmetric shielding as helium-3. Once again, the neutron is protected by the charge stream wrapping around the neutron and the intake of the vertical axis proton. This is the view that the charged wind sees. Why is carbon-14 unstable? Why does it have a 5,700-year half-life? That's nearly stable. There is room to add a second neutron to the shielding proton, similar to helium-4. Helium-4 is stable. But carbon-14 isn't? That doesn't make sense. Unless you look at the amount of mass behind the shielding proton. Helium-4 uses the secondary proton's equatorial emission as a rudder, reducing the effective mass of the secondary proton when aligning to the charged wind. Carbon-14 has a carousel behind it. Let's see what the charged wind sees. The one neutron is hanging out in the breeze. The only thing holding it in place is the charge feed stream and the vertical axis proton's intake. Push hard enough on the shielding proton at just the right angle, and the dangling neutron is pushed down the tube created by the 120-degree split at the carousel. When it hits the carousel center proton's equatorial emission, it will roll into place at the tail end of the carbon atom. This is the nitrogen atom. If subscribe, and next time we will see how these carbon and hydrogen atoms bond to form ethane, ethene, ethene, methane, and benzene at the least.